Refrigeration and air conditioning construction, maintenance business. Japan Association of Refrigeration and Air Conditioning Contractors. Places where refrigeration and air conditioning facility is used. Refrigeration and air conditioning facility is used in a variety of locations, including air conditioners in buildings, display cases in supermarkets, frozen and refrigerated warehouses, fishing boats, and food processing plants. In the speech bubble on the screen: office buildings, telecommunications, civil engineering and construction, transportation, air, livestock, civil engineering, brewing, power transmission, forestry, agriculture, fruit, agriculture, households, agricultural research laboratories, public facilities, schools, machinery industry, waste heat utilization for road surface freeze protection, fresh produce markets, civil engineering, fishing, commerce, transportation, land, transportation, sea, low-temperature warehouses, chemical plants, power stations, food processing industry, hotels etc., hospitals, transportation. Source: the Japan Refrigeration Air Conditioning Industry Association. Work practiced by technical interns in Japan. 1. Design. 2. Construction sites. 3. Inspection and maintenance. 1. Design. Based on the architectural drawings by CAD operators, we coordinate with other trades, electricians, plumbing, sanitation, and other construction workers, regarding pipe fitting and construction methods, and drawings of facility and construction are prepared for on-site workers. This figure shows an example of a system for general building construction, for example, for offices, for the layout of refrigerant piping related to refrigerant air conditioning equipment. Drainage piping for refrigeration and air conditioning equipment. In the case of recent in-ceiling equipment, it is difficult to obtain a drainage gradient within the ceiling, so a pump is used at the outlet of the equipment to raise the drained water temporarily to a higher level. 2. Construction sites. Before work, after lunch break, at the end of work, etc., workers, site supervisors, refrigerant pipefitters, electricians, thermal insulation workers, etc., are reminded of measures to avoid dangerous work on that day and the next day's work, called Kikenyachi training, which means hazard prediction. At the end of the meeting, we raise safety awareness by shouting "Stay safe." Refrigerant piping installation. Copper tubing is processed to the specified lengths and angles using a pipe bender. When connecting copper pipes, which are often used for refrigerant piping, there are two main methods: brazing and flare joints. See below. Brazing is defined as welding using a brazing filler material with a melting temperature of 700 degrees Celsius or higher. It is performed using an acetylene welder and hard brazing material. This is called phosphor copper brazing. Note that soldering performed in hot water supply work, etc., is defined as using a melting temperature of less than 450 degrees Celsius, and can be performed with a portable gas torch. The piping is heated and the brazing material is drawn into the gap by capillary action. During this process, a small amount of nitrogen gas must be poured into the piping while brazing, to prevent the formation of an oxide film on the inside of the piping. Failure to do so will allow debris to enter the refrigerant system and cause the adverse effects described in the vacuum drying process. Nitrogen gas flow inhibits the formation of oxide film inside the piping. Flare joints are a connection method used for copper pipes with an outer diameter up to 19.05 mm. A flare tool is used to flare the end of the copper tubing and then tighten it to the flare fitting with the appropriate torque. An airtightness test is a test in which gas pressure is applied to the piping connection to the specified pressure to check for leakage throughout the equipment, and then the pressure is checked to see if there is any drop. If a leak is suspected, the leak is found and repaired by applying a foaming agent around the joints and running the airtightness test again. The test is only passed if there is absolutely no leakage. If foreign matter, such as dust, air, moisture, etc., gets into a refrigerant system, it will not be able to deliver its full capacity, and in the worst case, it can be directly related to equipment failure. Fluorocarbon refrigerants, in particular, are extremely sensitive to moisture. Therefore, after piping is installed, it is necessary to remove any air remaining in the pipes and equipment, as well as any moisture contained in the air. This process is called vacuuming or vacuum drying. Vacuum drying requires a high vacuum to evaporate moisture, necessitating a dedicated vacuum pump. At the same time, a gauge manifold and vacuum gauge are needed to connect to the system. Also, depending on the size of the refrigerant system, vacuum drying can be completed only after about 15 to 30 minutes for room air conditioners for home use and 24 to 48 hours for office buildings. Vacuum is maintained for final leak inspection. Once the equipment has been vacuumed, it is filled with refrigerant as needed. The amount of refrigerant used depends on the size of the equipment, that is to say the pipe length, and the equipment manufacturer. If the amount of refrigerant is too large or too small for the equipment will not perform at its normal capacity, and in the worst case, the equipment will fail. On the other hand, packaged air conditioners for stores, and room air conditioners are often shipped with refrigerant sealed in the equipment. After vacuuming is completed, the equipment can be opened, but if the piping length exceeds the specified length, additional filling is required. Refrigeration and air conditioning work is not complete once the piping work is finished. It is necessary to perform a test run to confirm that the system is producing its rated capacity. This test run and adjustment is also used to check for excess or deficient refrigerant fill. Cooling units for a low-temperature warehouse are lined up in the upper left of the photo. Each unit is equipped with refrigerant and drain piping, power lines for fans, and control lines to maintain a constant temperature inside the warehouse. The refrigerant piping connecting the warehouse cooler inside the warehouse to the outdoor unit has been installed according to the design drawings. In addition, since the refrigerant piping becomes cold and condensation occurs, heat and moisture insulating materials are installed and protected by lagging, piping covers. Installing a cooler equivalent to the indoor unit of a room air conditioner, left side of the photo, indoor unit for commercial use such as office air conditioning, right side, unit cooler used for food freezing and refrigeration. 3. Inspection and maintenance. After delivery to the customer, the facility is periodically inspected for refrigerant leaks and equipment operation status by a knowledgeable person. National Skills Competition. The National Skills Competition, which aims to improve and pass on refrigeration and air conditioning skills, is held every year. The younger generation is very active in this competition. The winner is eligible to compete in the World Championship. Japan Association of Refrigeration and Air Conditioning Contractors. Purpose: promote global warming prevention and ozone layer protection. Provide members with up-to-date information. Promote energy conservation. Organize various seminars. Research and provide technical information. Members: the members are 37 member groups located throughout Japan. Each group includes 3,369 member companies. Business. We design, install, inspect, and maintain refrigeration and air conditioning equipment. We are a group of engineers with various technical qualifications. When equipment is disposed of, fluorocarbon are recovered to prevent global warming and protect the ozone layer. We're looking forward to the day when we can work with you all in Japan.